Okay, Math 2 folks, we gotta finish this unit up. So here's our unit review. Just before I begin, I just want to remind you about the importance of proportions. That what we're saying is, if I have big triangle and small triangle, if we have side A, if we divide the big side by the small side, that's going to be the same no matter which side we're choosing. That's going to give us our scale factor. Scale factor. And this is the principle that we're using over and over and over again, is saying if we know that they're similar, then we can apply this proportionality. So if your test doesn't have a lot of proportions set up on it, you're either doing a lot in your head on your calculator or you're not doing it correctly at all. And I encourage you, show your work. Tell me what you're doing on your test, because I've had so many tests where I think, well, maybe they got something right, but I don't see any work. So here, notice we're told that this is 8 and this is 12 in our problem. Notice, look, I've got a triangle here, and then I've got a larger triangle here. Now we know that a dilation, if it's dilated, that means that it is similar, because we've got similar angle, and we're saying all these sides scale proportionally. So the fact that it's dilation already tells us that it's similar, so we can use this proportionality. Scale factor is going to be big over the small, so the big one's 20, the small one's 8, and that's going to be 2.5. Now I would also accept if you did it the other way, 8 over 20 or 0.4. That's fine as well. I'm not going to be grading off the scale factor based on whether did you do it in the right order, but can you show me the proportion? So it's one of these two. If PS is 13, so the small one is 13, what is AD? So 20 over 8, right? 20 over 8, big over small, is what over 13? That's another way of doing this. Now, those of you that are used to scale factors could say, oh, I just multiply it by 2.5, and that's true. And so you should get 32.5. So create a similarity statement with two triangles in this figure. Well, I showed you two, so we could say that OSP is similar to ODA. But there are other triangles. There's this triangle here, and there's this triangle here. Question 2. Are they congruent, similar, or neither, or we don't have enough information? Well, I see that 9 and 18, 18 over 9, is the same as 12 over 6, is the same as, oh no, I don't have a third side. Not enough info. This one. So I want to check to see what my angles are. So we can say that the angles of a triangle add to 180 degrees. So this must be 53. Oh, look. Angle, angle. So we know that there's angle-angle similarity. So this one must be 42 degrees. And not only that, but look, we see that between 85 and 42, and 85 and 42 is 6. So our scale factor is 1. In other words, they are not just similar, they are exactly the same size as well as the same shape. In this one, I hope you can see this in the printout, we're saying these angles are similar. So I've got two triangles. I'm going to draw the smaller one out in the same orientation. So this is triangle MNP. MP is 8, MN is 4, and we know that the angle is the same. So I've got a side of 12 and a side of 8. So I know that the angle is similar. 12 over 8, is that equal to MR over MN, 6 over 4? Well, in each case, it's 1.5. So yes, they are similar. The reason why I don't have to check the third side is because I know the angles are congruent. This one, I don't know the angles, so I can't say, oh yeah, they must be similar. I'd have to know either this angle is congruent, or I'd have to know that those sides are also proportional. So there's why there's not enough information here, but here we're saying that they're similar. And this is side angle side. Okay, we already told that they're proportional here. So we know that since they're proportional, this must be 62 degrees. So the measure of angle L must be 180 minus the 90 degree right angle minus 62. It has to be 28 degrees. And then I've got this 8 to 16 proportion. So 16 over 8 equals 34 over x. 16 over 8 equals y over 15. So x is going to be 17 and y is going to be 30. Use the diagram below to answer the questions to the right. Find the scale factor. So let's look. I have angle. I have angle. So I have angle-angle similarity. So I know I have angle-angle similarity. Now I have to match corresponding sides. So since these angles are similar, that must mean 10 and x are corresponding sides. So I'm going to have 10 over something must equal x over something. And then I notice that these are corresponding sides. So 10 over 4, side AB, must equal x over 10. So you see how I've said this side should be proportional to this side in this triangle, the same way this one is in this triangle. So this gives me 4x equals 100. So x equals 25. So what's my scale factor? Well, 10 divided by 4. No, let's see. 10 divided by 4 equals 2.5. Or other way around, 4 divided by 10 is 0.4. So I'm using this one and this one to find my scale factor because those are corresponding sides. And now I need to find W. So that means W, another way to think about this, if we want to set up the proportion, you say, okay, I know my scale factor is 2.5. So that means W times 2.5 is going to give me the larger one. Excuse me. Or 17.5 times 0.4 is going to give me W. That'd be another way to do it. I'm going to do this. 10 over 4 equals 17.5 over W. You see I match corresponding sides, 10 over 4, 70.5 over W. So W is going to be, cross multiplying 10W equals 17.5 times 4, 70. So W equals 7. And I already went over this, but what similarity postulate allows us to conclude the two triangles are similar? This is angle, angle. We can't say side, angle, side because we don't know this side or this side. So we can't know until we know that they're similar, that those proportions are what. All right. Question number 5. We're trying to figure out if these lines are parallel. Well, these lines are only going to be parallel if the triangles are similar. So if the triangles are similar, then we're saying that we'd have not just one angle, but all of these angles would be similar. So the question is, are those congruent angles? If they are, then these would be parallel. But if not, then they wouldn't be parallel. So that's why I'm trying to check for similarities. I don't know that these angles are. I have to check for similarity. Well, since I don't know the angles, I'm going to have to use sides for similarity. So I'm going to say, is this triangle ADC, That's 7, 8. Is this triangle the same as this triangle? 8 plus 3 is 11. 7 plus 2 is 9. I know that the angles are the same. I need to see, are the sides the same? Well, 8 over 11 would give me a scale factor of 0.72. 7 over 9 would give me a scale factor of 0.77. So, not same scale factor, not similar, therefore not parallel. Okay. Similar argument here. We're going to say, look, this is 6 and 4, and this is 15 and 10. So is 6 over 15 the same as 4 over 10? 6 divided by 15, 0.4. 4 divided by 10, 0.4. Yes. Sides are proportional. Okay. All right, number 6. Number 6 is showing whether they're similar or not. You can see we know nothing about the angles. They don't share any angles, but they do share sides, so we know that we've got a small triangle here that is 8, 6, and 3.2. Now to check to see if they're similar, I have to check to see if every side shares the same proportion with its corresponding side. So is 15 over the 6 the same as 3.2, no, excuse me, 15 over 6, same as 8 over 3.2, the same as 20 over 8. Those all have to be the same, or else I don't have side, side, side. So I'm checking for side, side, side. 15 divided by 6, 2.5. 8 divided by 3.2, 2.5. 20 divided by 8, 2.5. Yes. Side, side, side. Number 7. Well, I only know 2 sides, a side and a side. And those sides, I don't know 2 sides on each triangle. So I certainly can't do side, 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 not nearly enough information. If I were looking for side, angle, side, I would need another side on each triangle, so that doesn't work. So I'm left with angle, angle. And do I know that? Well, sure. Angle, angle. So yes, by angle, angle. And since we know that, we could say, oh, look, I have 2 sides. I know that they're similar, therefore I know that there's a scale factor and I could calculate. But it's the angles that tell us the similarity. Number 8, Sergio Romo wants to estimate the height of the stadium lights at AT&T Park. To do this, he places a mirror on the ground. 300, so here's my mirror. This is going to be 350 from the base of the lights. Those are lights. So there's 350. Then he walked backwards till he can see. So he's looking at these lights through a mirror. He's 10 feet, and his eyes are 5 feet above the ground. I think he might be not quite that short, but so we're saying, look, since these angles, mirrors mean those angles must be similar, we're saying this must be proportional. So 5 over x equals 10 over 350, or 5 over 10 equals x over 350. Either way will work. You'll note if we cross multiply, each case we're going to get 10x equals 5 times 350, which is 1750. So we have x equals 175. In class, I told you you need this information. 12 and 4 there. So I want you to, if I look at it this way, I can see that I have a triangle, a small triangle here that is 12 x and y, and I have a large triangle that is 16, 5 plus y, and 9. Well, I can't determine the scale factor from these because they are not, there's variables here. But here, from 12 to 16, I can determine that. So what I can say is that the small triangle over the big triangle, and you could do it either way, is 12 over 16. So then I can take another one. Let's do small triangle over the big triangle. So x must be, I could cross multiply. 16x equals 12 times 9 equals 108. So x is going to be 6.75. Okay, and let's see, 6.75. And do the same thing with y. So look, I've got two corresponding sides that each have a y in it, but as long as I have a pair of corresponding sides that doesn't have a variable, I can work with that. So 12 over 16, small over big, equals small y over big, 5 plus y. Cross multiply, 12 times 5 plus y equals 16y. So 12 times 5 is 60, so I have 60 plus 12y equals 16y. Subtract 12y from both sides, and I get 4y equals 60. So y divided by 4 is 15. All right. So there is part 1. Part 2 will be coming up shortly.